Hey guys, how are we going? Welcome to another episode of Idle Instructions. And today we're going to be looking at this little guy over here. So this is what's known as a potentiometer. It's a little component that has 3 pins. We've got 2 pins on one side and 1 pin on the other side for this one. And it also has this knob at the top which we can turn counterclockwise or clockwise. And then this will adjust the resistance on the fly of this part of the circuit. So essentially in our old circuit where we put that resistor in to determine how bright our LED would be, this guy can do it on the fly and we can actually dim the LED as we go along. So it sort of works like a dimmer switch in your house. And so this can change it without having to add in all the little resistors and different values to try and figure out different brightnesses for LEDs. So let's pop this guy in the circuit and we'll show you what it looks like. So here we have the circuit all wired up. So it looks a little bit different to our old circuit. So we've got our wire coming out of pin 12, still the same, coming into the hole there. We've still got our old resistor here, and this is there just so that we can have a sort of safety net, because basically this potentiometer acts as a resistor, but if we turn it all the way in one direction, it essentially has zero resistance. So we could potentially blow up our LED again with excessive current. So this resistor here is to sort of just keep a baseline and set the maximum that we can have our LED light up, essentially. So after this resistor, we've got the potentiometer wired in next. So it's connected through one of the columns here, or rows, sorry. And then that connects to the potentiometer. Then the third pin, that singular pin that was on the back of the potentiometer, connects here, and that joins with the LED. And then we've just got a couple of wires here just to join us back to ground, which is the final point in our circuit. So the LED's here, it's lit up. And if we turn this, we can actually dim the LED. So I'll see if I can get it. It can be a bit tricky here. And so if I turn it, that's the wrong way. If I turn it this way, the LED gets brighter. So as you can see, the LED is quite bright there. So this is where this potentiometer is essentially at zero resistance. It will just allow the current to pass through, so that this resistor is the only thing that's stopping excess current coming through. And then if I turn it the other way, sorry it keeps turning off and on, it's just because this keeps coming out of the hole. So if I just turn it, and we can slowly dim it. So as I turn it anti-clockwise this way, we're actually adding more resistance as we go. So it's essentially like adding a lot of these guys in without having to add a lot of those guys in. So if I turn it this way, we can make it bright again, and we'll just do it one more time and make it dim. So this is how the potentiometer works as a dimmer, but we can also do another cool thing with it. We can actually read the value of the potentiometer and at what stage of the turn we're at, and use that to control certain things. So we'll have a look at what we can do with that next. So here we go, we've got our new circuit set up. So this one we've got 2 parts. We've actually got the normal LED circuit that we had in the first video. So this one is just the one with the resistor and the LED, and then we've got it blinking off and on. But we've also got this other section over here. Now this one has the potentiometer, but this time we've actually connected up all 3 pins. So in that last circuit, one of the pins on the front of those pairs that were in together, one of them was just sort of left hanging there and it wasn't actually used at all. In this one, we've actually used all 3. And so we've got the yellow one here connected to 1 pin, and that's going to a 5-volt source on the Arduino. So this is a different voltage source than the pin 12 that's powering the LED. Then we've got this blue one on the back here. So this one's connected to the center pin, and this one's going into an analog pin of the Arduino. Now the analog pin is the one that reads in sort of like a variety of values from the potentiometer. Unlike the digital pins, like the one that's powering the LED, which just has an on and off or a high and a low setting, the analog reads in sort of a continuous range of data from a sensor or source. And so we're connecting it to pin 4 over here. And then finally, we've got this orange one that's connecting us back to ground, which completes the circuit. And that's connected to the other pin on the front next to the pin that's connected to the 5 volts, as you can see here. So what does this do? So basically, we've got the code up here on the left now. And so you can see it looks very similar to the old code we had to blink the LED off and on. But now we've got a few different things in there. We've got the potentiometer pin, which is number 4. We've got a sensor value, which will store the value that's stored by this blue pin going into the analog pin 4. We've also got the pin mode, so this is just setting the LED pin to be on again. We're going to start a serial transmission, and we'll go into that in more detail in a later video. And then we've got the loop. So in this loop, we're going to pick up the value of this potentiometer and where it's at by using the function analog read. And so we pass it the pin that the potentiometer is connected to, that middle pin here, and that will give us a value. This serial print line will then print the value on our computer screen so we can see what's going on. Then we have the exact same code as before with the LED blinking, but instead of delaying just by 1 second, we're actually going to use the value that this potentiometer is giving us, like the rate of the turn or where it's turned to. And so that way we'll actually be able to control the speed at which this blinks by turning this potentiometer. And so what happens is when it's on and I open up the serial monitor, which is in the tools, it will slowly show us the values that the potentiometer is reading. So right now it's giving us a value of 1023. Now this is the highest value it can give us. The reason being it's 1023 is because the Arduino accepts analog signals and has an analog to digital converter that has a 10-bit size. Don't worry about any of that. We're not going to be learning about that in this video, but we just got to know that this is the highest value that it can give us. And then what happens is if I hold this potentiometer in, because it's a bit loose, it can be a bit annoying sometimes, and if I turn this guy, we should see the number start to go down. So there we go, we got 747 there. And then if I turn it a bit more, 645, it keeps going down, it keeps going down. And then if we keep going down until it's very small, you'll notice that the LED is blinking like crazy. Now, this is because this sensor value is now decreasing. I'll just open up that monitor again. So this sensor value was 1023 before, which was about a second, but now it's gone down to 110 milliseconds. So now this LED is blinking on and off every 110 milliseconds instead of 1 second. And this is based on the reading that we're getting from this. Now, you might be wondering, how does this Arduino know? Like, what's it actually doing to try and figure out where this potentiometer is at? Like, why does connecting all 3 pins and connecting this middle pin to this pin figure out this value? And what exactly is this value? Like, why does it stop at 1023? And so for that one, we're going to be looking at an interesting thing in electronics called voltage dividers. And we'll also be looking at the internal structure of a potentiometer. So let's jump to the book and we'll write some stuff out and get to it. So here we've got a drawing of the internals of the potentiometer. So what's going on here? So we've got the 3 pins. So these are the 3 pins that are on this guy. So this one, let's say it's this one here. We've got this one, that one, and then the middle one that's on the back is this guy. So basically, the potentiometer has a long resistive track on the inside. Now, this is a track that can conduct electricity, but the further the electricity has to pass through this, the more resistance it's going to experience. So with length of things can determine the resistance. So for example, if I got this jumper cable and let's say I made it a bit longer, so let's say to there, it would actually provide more resistance for the electricity. So this track sort of runs under that principle. So basically, the electricity will come through here, it will hit the beginning of the track, and then it will flow through until it can find a way to exit the circuit. So basically, it will come up through here, and it will keep going until it hits this wiper here. So this beam here is pretty much what we're turning when we turn the knob at the top like that. So when we turn this, it will dictate how far the electricity has to travel before it can actually exit off this track and down to wherever we connect this pin to. Now, it will only travel down that pin if it's finishing the circuit, so if it's going back to ground or going back to the Arduino. If we just let that loose and we didn't connect it to anything, it wouldn't go anywhere. So then we have the final pin. So the final pin's at the very end of the track. Now, this one we didn't use in the dimmer switch circuit. We didn't actually connect this to anything. And the reason being is that we wanted the LED to only use this section of the track, or whatever section of the track was available until it hit this wiper. If we had connected this up to ground or to finish it off, the electricity could have just gone straight around and it completely ignored this wiper because it had another way of exiting and finishing the circuit. So with the analog reading circuit, we actually connected all three. So you might be wondering, okay, so the electricity comes through here, it comes up here, and it can go this way to go to the analog pin on the Arduino, or it could keep going and just finish the circuit here, because both directions end up completing the circuit. And it sort of does that, but the reasoning behind putting this pin in and this pin in for that circuit can be explained using the voltage divider. So I've got a drawing of a pretty basic circuit over here. I've also got this happy little man over here, and we'll explain what he's all about later. So in this circuit, we've got a 5-volt power supply, just like that comes from the Arduino. We've got the cables, and then we've got a resistor labeled R1, and then we have another resistor labeled R2. So we've got two resistors in this circuit, and then we've got this bit jumping out here that says V out. Now we'll explain that a bit later. But basically, circuit with two resistors and then completes the circuit. Now it's time for a pretty crazy analogy. So let's say this is a circuit, like a fitness circuit. And say we've got two challenges in this circuit. And we've got our little guy here who is going to go out and try and smash these challenges as fast as possible. Now, let's say for this little guy, he has a total capacity of 5 kilos. Let's say that's the max his body can lift or put out to carry anything. And let's say he uses this capacity as he goes through the circuit. Now, he knows he has two challenges. He's got R1 and R2. Let's say this is jumping over a fence and this one's climbing up a rope or something like that. It could be anything. He knows before he completes the circuit the difficulty of these two. He knows how much challenge it's going to throw at him. So he goes, okay, if the challenge proposed by this R1 is quite big compared to R2, he knows that he's going to have to use a lot of energy for this one to get it over and done with, and then this one he won't use as much. If both resistors are pretty much the same, or both challenges, sorry, if both challenges are pretty much the same in the circuit, then he knows to balance out his energy and he can just use an even amount between the two. So say our guy comes through here, and let's say they're even, let's say that the challenges are equivalent. He will go through the challenge, and then once he gets here, his capacity of 5 kilos before goes down to 2.5 kilos because he's used half of his energy. Now he only has the other half left. Then he just has enough to finish off the final challenge. Now, if it wasn't even, and say R1 was really big, it was a really big challenge, he might use, say, 4 kilos of his energy to try and get over that hurdle, and then he will only have to use 1 for the R2. And so he will just adjust that based on the difficulty of these two challenges. So, pretty weird analogy, but essentially it works the same way with voltage. When voltage comes out, it sort of knows what the resistant values of these two things are, and it will drop accordingly depending on how big these resistors are in relation to each other. So if we've got 5 volts coming out here, and these two resistors are even, in other words, they both equal, say, 330 ohms, the drop in voltage between this point and this point will be 2.5. So just like our little guy here, we know how much he worked to get past this by comparing how he was here and how he was here. Here he could carry 5 kilos, here he could only carry 2.5, so we know he dropped 2.5 kilos across this. If he could carry 5 kilos here and could only carry 4 kilos there, then we know that he dropped 1 kilo, so we know it was a 1 kilo drop between these 2 points. So voltage works in a very similar way. You have to connect 2 points to figure out what the drop in voltage is between these components. So this is what this V out is essentially. So this circuit divides this voltage. So we've got 5 volts and we want to divide it into 2. So as we saw before, there is a drop that happens across this resistor and across this resistor, and that actually splits the voltage. So again, if these are two equivalent ones, say 330 ohms, we know that the drop between here and here is going to be 2.5 volts. It's going to be half of 5. And so this is what the V out is, and that's what the voltage split is. You can actually calculate this using a formula. So there's this V out equals V in multiplied by the value of the resistor 2, and that's in ohms, divided by R1 plus R2. So an example of that would be for V out equals, say, let's say this is 5 volts, so we know that. R2 is, let's say, 330, and let's say R1 is also 330. So we have 330 divided by 330 plus 330, which is 660. So we know that 330 over 660 is a half. A half times 5 is 2.5. So you can use this formula to figure out what the voltage drop will be across here and what you've divided your voltage by. So you might be wondering, okay, what does that have to do with a potentiometer? So a potentiometer is essentially a voltage divider. Whatever part of the resistive track is before the wiper is our R1 resistor down here. The bit that extends beyond and goes to this pin is our R2. You can sort of see it. So if the electricity comes out here and gets to the first resistor, our electricity comes up here, it gets to our first resistor, then it hits this point where it can branch off. It can go across here or it can go through our resistor 2. So same here, we can branch off to our analog pin or we can keep going to the very end. So this is the equivalent of this split off just here. And so when the electricity passes into the analog pin, which is this equivalent just over here, what it does is it actually measures the voltage drop that's occurring between here and the end of the track or ground here. So this is what it looks like in the voltage divider circuit, and then this is what it looks like in the potentiometer. It looks like the voltage count between here and here. And so when I turn this potentiometer wiper down towards the 5 volts, we can see that the voltage drop for R2 is going to be quite large because we've got quite a lot of it to go. And so it's sort of the equivalent of this R1 being incredibly low in resistance and this R2 being incredibly high in resistance. And so if we turn it away from 5 volts towards here, that's the equivalent of making R1 incredibly big and making R2 incredibly small. And so in the Arduino, when we open up that serial monitor, it comes out with a number that tells us what the voltage drop is between here and here. Now, it does it in a weird way. It does it from the numbers 0 to 1023. And this is just because of how the Arduino has to handle an analog input. You can actually convert that to the voltage. So I'm just using my phone calculator here. So basically, if we go 5, which is our voltage, divided by, let's say, the max value. So 1023 is the highest value that we can get for the Arduino reading. We get this. And so what this tells us is that for each one of those values, so 1, 2, 3, 4, 5, up to 1023 in that serial reading, each one of those is the equivalent of 4.88 blah 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 millivolts. So this is in volts, so it's divided by 1,000, so you could say this is 4.88 millivolts, or 0.004 volts. And so, for example, when we got that reading of 747, we can times that by 747, and so we got a value of 3.65. So that means that when I was turning this guy, and I got a value of 747, the voltage drop between the wiper and the very end was 3.65 volts. And so the Arduino can actually read this voltage difference and then tell you what it is. Now, we just arbitrarily used it to set a timer for how an LED blinked, but you can use this for anything really. It's just a way of getting a range of inputs, and we can use that to control whatever component we want, essentially. So I hope you guys found this video informative, and I'm looking forward to seeing you in the next one. Goodbye for now.